Okay, so we talked about this cluster membership and the fact that a record can be a member of just one cluster. That's the image on the left. Or a record could sort of be possibly a member of cluster 1, but also possibly a member of cluster 2 with, say, 10% chance of that, and a 30% chance of being a member of cluster 3. Okay, the next kind of process that we're going to talk about besides classification and estimation and clustering is something else called association mining. And we'll get to this in much more detail later, but here we have what's called a transactional database, which basically means you just have an ID number and a transaction that occurred. Usually this is like in sales. So this might be like a grocery store or a shop or some kind of store. So at this grocery store, the first, or here we have a purchase. Person bought an apple, a Coke, and an MP3. And the second order here was someone bought bread, Coke, and eggs. And then the third one was apple, bread, Coke, and eggs, and bread and eggs. So we have these purchases that occurred, and we might look for kind of common patterns in these purchases. For example, if people buy apples, do they usually buy something else? If people buy bread, do they usually buy something else? If people buy eggs, do they usually buy something else? So, for example, we might come up with a rule, like here on the right, that if people buy apples, then they usually buy Coke. Or we might come up with a rule like if people buy bread, then they usually buy eggs. Or we might come up with two on the left. If they buy Coke and eggs, so that's like a conjunction. Remember, we call that a conjunction. If this and this, if they buy Coke and they buy egg, then they buy bread, and so on. We could come up with these rules. Now, you might say, well, these are just if-then rules that we saw before, so aren't these just what do we call them? Anyway, classification rules or something like that. But the thing that's different here is that with classification rules, we always have in mind a particular output. So we have in mind, for example, that we're trying to predict whether something is an iris virginica, setosa, or the other one. So that's the output, the class. We always have an idea of what the class variable is. Or we had another example of whether someone's a good candidate for a loan or a bad candidate for a loan. So again, we have the idea of the thing that we're trying to predict is whether which class they're in terms of good or bad loan candidate. So we have that in mind, the class variable. Or if you recall the game, the golf game, we were trying to predict whether they were going to play or not. So we weren't trying to predict like the outcome, the outlook for the weather, or the humidity for the weather, or the windiness. Those were always considered to be the input variables, and we were trying to predict whether they were going to play or not, and that was always considered to be the output variable. But here, in this association mining, we don't have a specified output. So that's why this is sometimes called unsupervised, because if you recall the definition of supervised versus unsupervised, unsupervised was when you don't have any particular output variable. So in a sense, that's what we're doing here. We don't have a specified output variable, so sometimes association mining is considered unsupervised, like clustering is called unsupervised also. Okay, so association mining identifies co-occurrences of groups of data items in a data set. So looking for co-occurrences. Such associations may exist between values of the same variable in the above example, we could say that all the values are for the same variable, purchases. So the variable might be purchases. So we're just looking within purchases for associations. Associations may also be found between values of different variables. Associations may occur in temporal order, and then they're called sequential patterns. So if this happens and that happens, then something else will happen. So if you're talking about things happening in a time sequence like that, if first this happens, then that happens, then we expect something else to happen, we can call them sequential patterns, but still we can be looking for. So sometimes this will be used when people are analyzing traffic at a website. For example, Amazon might be interested in doing something like this. They might say, if someone clicks on this page and they click on that page, then they're likely to go to the checkout page. But if they click on this page and then they click on another page, then they're likely to leave the site. Okay, so that's something they might like to examine, to look for. Okay, but in that case we call those sequential patterns. An example of association mining is to identify significant associations between products on sale in a transaction database as shown above. So this is a typical example of association rules up here. The association mining method can find what are called association rules in an if-then clause format. For instance, the method, so the famous example of association rules is this. The method has found that a customer, so if we're looking at they did this supposedly at a supermarket, and they found that people who buy bread also buy eggs. Sorry, that's not the example I thought of, but okay. So people who buy bread also buy eggs. So suppose that you had that rule. One area of practical application for association mining. So when is this used? When can this be used? Who can use this? How can they use it? I said that Amazon might use it, but here in supermarkets is the retail industry, such as supermarkets, shops, and supply chains, etc. However, association patterns have a much wider range of applications in general. Once information patterns are mined, so okay, the next thing we want to do is talk about how do we evaluate our data mining results. So suppose we get, well, we saw this already when we looked at the iris prediction, and we saw that it was 98% accurate. So that's one measure of how good the process was. So we need to examine, or we want to examine, different measures of how good the results are. Okay, so this is evaluation of mining results. Once information patterns are mined from the input data, they should be evaluated. Without proper evaluation, patterns may reveal relationships that happen by chance. So we might find these if-then rules, for example, that are just very small likelihood that they're correct. So we need to know how accurate they are, how likely they are, and basically we need to evaluate how good they are, and may not lead to any useful actions. Then the patterns are hardly of any practical use. How to evaluate patterns has been an active area for ongoing research since the inception of data mining. Various measures have been suggested, broadly known as measures of interestingness. These measures evaluate, so that's one type of discussion we're going to have. These measures evaluate conciseness, coverage, reliability, peculiarity, diversity, novelty, surprisingness, usefulness, and applicability of the patterns. So now I'm just going to scroll through this, and I'll let you stop the movie and read this yourself. I'll just scroll through it now. Conciseness, coverage, reliability, peculiarity, diversity, novel. Okay, and next thing we're going to do now is review basic concepts of probability and statistics. And here, also, I'm not going to go through this. I'm just going to scroll through the screen, let you read this at your own speed, and then you can answer the homework questions. Okay, so here's the homework. Please hand this in through Blackboard. Okay, this one is go to the UC Irvine Machine Learning repository there. You will find many data sets. Find two that could be related to classes that you are taking or have taken or could be related to your major. And if you can't find any at this repository, then find data on the internet that would satisfy the same classes that you've taken or something like that. For each of the two data sets, address the following. Describe the data sets and how they might be relevant to your studies. Is there any classification estimation problem that could be analyzed based on this data? What variable within the data set could be an output, a target variable? And how might this data be analyzed for clustering purposes? I mean, what kinds of useful knowledge might you get from the clustering of the data? Okay, that's all.